In this video, I'm going to illustrate how to import raw data into the LISREL program and to run a couple of statistical models. Basically, I'm going to run the same models that I did in a previous video where we were using syntax and basically typing in correlation and variance covariance matrices. Here we're going to take the data that we used in that video and basically just import it directly in to LISREL so that it will automatically do this for us. And then we can run our analyses. So this is probably what is probably one of the most common way in which people would actually go about running SEM models in LISREL. So here we have a data set in SPSS that's open. So we've got 6 variables: subject matter interest, intrinsic motivation, anxiety, cognitive engagement, work avoidance, and achievement. We have 100 cases in this particular data set. So I've already saved this particular data set. And so now what I'm going to do is I'm going to open up LISREL. And so as you can see, when you open up the program, you have just basically a blank workspace. And then to actually import the data, you'll go to File, you'll go to Import Data, and I'm going to go under Example 2 here. Now you'll notice that down here you have this little box that says it defaults with free format data, so a DAT file or a raw data file. But if you click the little icon here, the little down arrow, you can look. There's different types of file types that you can work with. So you can see there's a comma-delimited data, CSV file, tab-delimited data, text file, SPSS data, and so forth. So I'm going to click on SPSS for Windows. And then you can see that the SPSS data file actually appears up here. So I'm going to click on this right here, and then I'm going to click on Open. Now, you're going to see in this particular case, and by the way, you also have to give the data file a name. So basically, what's happening is that you're in this case, the SPSS data file is going to be converted to a LISREL system file, and this is going to be fed into the LISREL program for data analysis. So I'm just going to leave the name. It kind of gives you a default name. You can name it whatever you want to. So I'm just going to leave it the same name as what my original SPSS data file was, and I'm going to click on Save. Now, here's the thing. You can see now that our box opens up. And so this is basically now in a LISREL system file. So in the past, the data file was actually called, it was a pre-list system file, but they changed the file type, and so it's several versions back. So it's called the LISREL system file. And so you can see that we have each of our variables. There's our variable names. You can see that we have all 100 cases on here as we scroll. Now, what you have to do in this particular case when you're working with your data is you have to kind of describe what the variables are, what their measurement types are, and how you're going to deal with missing data. So basically, what you do is you go under, we'll go under Data, and the first thing we'll do is we'll go to Define Variables. Okay, and so in this particular case right here, we have all the variables right here. If we wanted to rename a variable, we could. We could click on a particular variable name and rename it. We could call it, subject matter or whatever. It doesn't really matter. I'm going to keep it as SMI right here, subject matter interest, in that way. But you can rename the variables. You'll see under variable type that you have, when you click on that, you've got ordinal, continuous, censored variables, and so forth. And so Probably the most commonly used variable type is continuous, because oftentimes we assume that our data are continuous in nature. It doesn't mean that we can't carry out SEM with certain other types of variable types, but that takes a little bit more nuance and than what we're going to address in this particular video. So for this particular data set, we've got our 6 variables. We're going to treat them all as continuous. Now, and then so basically what we do is we're going to highlight all these, variable type, continuous. So basically it's going to, now when I click on OK, the program is going to recognize all 6 of these variables as continuous. Now, if it were the case that, let's say that I had a variable, let's say the variables were, items on a 7-point scale. Like, let's say I was going to do a confirmatory factor analysis or something like that, where people responded from 1 being strongly disagree to 7 being strongly agree. There would be, 7 levels in that particular case. And if and in theory, I could actually treat that data as ordinal, and then be running factor analysis, assuming the data are more ordinal. But I could still treat the variables as continuous, and that's oftentimes what we do with Likert types items. It's not necessarily the best way, but that's oftentimes the case. So we could click on continuous. Now, if I had a variable that I was treating as ordinal, but it had 15 or more categories, then by default, even if I had this clicked as ordinal, SPSS would recognize the variable as continuous. So that's just a little side note to keep in mind. So at any rate, for this particular data set, we have our variables. They're all being treated as continuous. Down here under missing values, this is basically what we do in order to deal with missing data. So in our current data set, we actually do not have any missing data. But if we did, we would want to give some kind of code for those cases that have missing values on particular variables. So in that particular case, if you just import the data directly from SPSS, and let's say, for instance, going back, let's say there was a missing case here, and there was a missing case right here, and there was no special code that we had assigned to those particular cases for those particular variables. In that particular case, what would happen is that when this opened up, LISREL would already give you a missing value code, and actually the missing value code would be -99999. So that would be the code. And the thing is that because these the columns are a little bit narrow, you'll probably see a bunch of the pound signs. But if you stretch out the columns, then you would actually see the -99999. So at any rate, we don't have that particular situation in this data set, so we're just going to leave it as no missing values. But if we did, then we could actually ask for certain types of deletion methods when we are running our analyses, or basically generating our variance covariance matrices and running our analyses. But we're not going to really get into that right now. This is just sort of a very basic introduction that we're working with. So at this point, I'm going to click on OK, and then you want to click on this little button right here for Save. Okay, so at this point, we have our LISREL system file. Now, if we didn't click on Save, then all the changes that we made previously under our defined variables would not take into effect. And to be able to actually run our analyses with this particular data set, we have to save our work. Okay, so At this point, what we'll do is we will now we'll want to run our data in LISREL. So we'll go to File, we'll go to New, and we'll go to Simplest Project and click on OK. All right, so now you have to basically you have to give your project a name. So I'm just going to call this New Project for short here, and then I'm going to click on Save. And so this box opens up. So this is the same box that I was illustrating in my previous video where we were typing in the syntax and everything. And so we could, in this particular case, now we can actually use a syntax editor to construct our model and so forth. So if you go to this little setup right here, you'll see that it's got information, basically options for specifying our model and specifying the syntax. So if we go to title and comments, let's say I'm just going to call this, I'll just call this path model. And I could have any comments down here and so forth. Then I'll press next. This is not really particularly useful in the context where we're just working with one group of data. So I'm going to click next again. And so now this little box opens up with labels and so forth. And so what I want to do is I want to read the data in from this LISREL system file into LISREL. So I'm going to click on Add Read Variables. And now I'll where it says Read from File, I'm going to click this little button and go to LISREL system file. And so in this particular case right here, then when I click on Browse, I find the LISREL system file. So here's the LISREL system file. So it's an LSF file. So I click on it and then on Open. And so now this is basically the LISREL program is going to read that file from what we've done before. So now I'll click on OK. And so now you can see we've got our variables. This is for constant right here, if we want to include constants in our models. And then at this point, now we can click on Next. And you'll see basically down here our variables appear. So these are all measured or observed variables. In this particular illustration, we're not doing anything with latent variables. I'm just going to illustrate a path model using just our measured variables. So at this point, I'll click on OK. And now the cool thing is that I can basically go down to Build Simplest Syntax and click on it. And so now you can see that you have the basic syntax structure. And if I was running this, running the path model using syntax, I would have to have a line for observed variables. I would have to have the information from the covariance or correlation matrix and so forth. But basically, I'm reading the raw data from this particular file right here, the LISREL system file, and basically this is containing all the information I need. So at this point, all I have to do is I can go down to relationships, and now I can actually specify my model. So, so I'm going to make this a little bit bigger. So in this particular case, what I can do is, I can type in my observed variables, or I could, use sort of a drag and drop. So in this case, I'll just use drag and drop. So I'll go down here to where it says Achieve, and I'll move it up. So that's going to be one of my endogenous variables. I'm going to say Achieve equals, and then I will type in I am and anxiety. Now here's the thing, sometimes it gets a little stuck, and so you can end up dragging more variables than you really want, so you have to be a little bit careful with that. I'll also bring up SMI as well, subject matter interest. Alright, so then I'm going to hit enter, and then I'll go to, oh, actually that's not what I want. I want to make this parallel to the previous video, so I'm going to actually make cognitive engagement. I see what I'm saying right here is it sort of took this variable right here and got a little stuck. So you sort of have to be careful not for that to happen, or to at least correct it when it does. So at any rate, now what I'll do is I will go to work avoidance, and I'm going to drag it, and I'm going to say equals, and then I'll include subject matter interest and anxiety, and then I'll do achievement as well. So I'll drag achieve up there, equals, and then I'll say engagement and work avoidance. Now, the default estimation approach in LISREL is maximum likelihood. So right now we're just going to run the model using maximum likelihood estimation. So in this case, now we just highlight and we press the little run guy right here, and you can see there's our basic model. So this is the exact same model as what we had in our previous video, where I was illustrating the use of syntax. So there's our chi-square value, our root mean square error of approximation. You can see you've got your estimates. This is the unstandardized solution. So basically, these numbers right here are the variances of the exogenous predictor variables. These are all covariances among those variables. You can see right here, this is a path from cognitive engagement, one endogenous variable to another, work avoidance to achievement, which is another path from an endogenous variable to another. And then these are all, as you can see, these are all direct paths as well from these exogenous predictor variables to the various endogenous variables. So at any rate, and I can go back to my output, and you can see right here, we have information. Now in this case, you've got information on each of the variables. So you've got skewness and kurtosis statistics for each of our variables. So you can see really, for the most part, things are looking pretty good in terms of univariate normality. So you can scroll down here, you can see tests of univariate normality for continuous variables. None of these are really significant. You got a little bit of significant kurtosis for SMI, but not much. And then you can see you've got chi-square p-values for testing kind of both skew and kurtosis, and then multivariate normality as well. And really this is not surprising because the data were generated, it's artificial data that were generated in SPSS so that it would be multivariate normal. So it's not a surprise. In real life, data oftentimes would not appear quite as clean. But at any rate, you see that you've got the basic models that are being specified. The sample size was read in as well. There's our covariance matrix. So this is pretty much what was typed in the previous video. And then going down, you see the structural equation. So these are all in unstandardized form. So these are unstandardized regression coefficients that we have right here, which we saw previously in our path diagram. We have the standard errors, z-values and p-values, and so forth. You have the r-square values associated with each set of each portion of the path model. And then, as you scroll down, you can see there's a covariance matrix of the independent variables, which are basically the exogenous predictor variables. And then you scroll down and you have your fit statistics. And so, as I showed you in the previous video, it gives you degrees of freedom for the analysis. Anything above, a degrees of freedom of 1 or greater would signify that you have an over-identified model. And in that particular case, you have a model, you can assess overall goodness of fit and have it actually mean something. So, so in this particular case, you can see that our chi-square test is not statistically significant. You also have you have the root mean square error approximation that's less than 0.05, which is indicating a close fit. Up to about 0.08 is considered a reasonably good fit or reasonably close fit to the data. Then you've got the norm fit index, the non-norm fit index. These values are above 0.90, and actually this one's close, a little bit above 0.95. So those are actually indicative of reasonably good fit as well. You've got the comparative fit index that's above 0.90, definitely above 0.95, which is a little bit more stringent. So that's actually indicating you've got good fit as well. And then down, as you look at the standardized root mean square residual, this is below 0.05, which is indicative of close fit. For the goodness of fit and adjusted goodness of fit, both of those are above 0.90, which again would be consistent with a good fitting model. So, kind of going back, let me just kind of rerun this for a second here. And as you can see, if we click on standardized solution, now in this particular case, what you're getting are essentially beta weights. In terms of the paths, so the paths are actually interpreted like standardized regression coefficients. Over here, for the exogenous variables, you can see each of these are 1, and that's because the variance of a standardized variable is 1. So there's no estimation going on there, but you do have, these are now correlations among the exogenous predictor variables. Then over here you can see that you've got the error variance associated with each of your endogenous variables. So in the standardized solution, you can basically look at this as the proportion of variation that's unaccounted for. So about 71% is unaccounted for by the predictors in the model for cognitive engagement. But that obviously means that 29% is accounted for. Over here, you've got 82% of the variance in work avoidance unaccounted for, whereas 18% would be. And then down here, you've got 21% accounted for by the predictor work avoidance and cognitive engagement. So if you go back and you just you go back and look at the R-square values, you can see that that's exactly the case. So at any rate, this was sort of a short and sweet introduction to how you can import data from SPSS. It also works, with CSV files and so forth. Actually, let me just kind of go ahead before I quit and just kind of illustrate that. So let's just say I take this particular data set right here. I'm going to put those values in. I'm going to leave dealing with missing data for another video. But in this particular case, let's just say I'll create a CSV file. So I'll just in this particular case, I'm in SPSS. I'm just going to create a comma-delimited file. And so, I could easily generate this kind of file using Excel and so forth. So in this case, I'm just going to call this SEM6VARS CSV file. So I'll click on Save. And so in this particular case right here, now I'm just going to import the data using that particular file type. So in this case, I'll just go to File, Import Data, and in this particular case, I'll click down here, comma-delimited data. So again, this could be easily generated in Excel, or if you had data in Excel and you wanted to run an SEM model on that data, you can import it just as easily using that particular file type. So I'm just going to give this a new name. I'll just call it 1, or add a 1, and make this LISREL system file now have a 1. Number of variables, the default is 6. It's got the variable names actually at the top of the file. So there you go. And you can see that sometimes when you import data, things get a little screwy with the labels or whatever. You can see right here it got a little screwy with our SMI variable. So, if I go to define variables, I'll just rename this. I'll just click on rename, and I'll just call this SMI, and then there you go. And so now When I click on OK, you can see that the name changes, and I can basically do all the same sorts of variable definitions that I was showing you before. And like I said, if you happen to have missing data, you could actually deal with the missing data in your original software program using whatever options are available there. In LISREL, you have a number of different options for dealing with it and basically generating a full data set, or finding other ways of managing the missing data. So basically, this is in pre-list or pre-list processor. So basically, you have a number of different ways to deal with the data. I'm not going to show you all those in this particular video. Like I said, this was just mainly to show you how to import data. Basically, like I said, at this point, we could take this data set and just do everything that we had done before in terms of generating our path model and running it. So that pretty much concludes this particular demonstration.